All right, guys. We're not gonna do notes today. What I want to do today instead is I want to go over a couple of problems from the previous assignments. Just because, like, we're gonna spend one more day on 13.1, just doing some problems. Just because 13.1 is really, really, really important for 13.2. I really want to make sure that you guys are really well equipped to start 13.2. Okay, so the first thing I'm going to do is do number 3 from from your last assignment. It says secant theta is equal to 2. I want to find cosine. Because I'm looking for cosine, if you guys notice here, secant is 1 over cosine, right? So if I know 1 over cosine is 2, that tells me that cosine, all I have to do is flip it, right? Like this is 2 over 1. I have to flip cosine to the top, then I flip the 2 to the bottom. So it's 1/2. So number 3 would be 1/2. Okay. Another problem I want to do, I want to backtrack a little. I want to take on number 1. It's tan theta is equal to 1. I want to find secant theta. Then my degree is still between 0 and 90. This part means that you're in quadrant 1, right? You're in quadrant 1. There's a lot of different ways you do this. A different method that... actually, no, I'm going to show you the way that... the normal method. I have tangent, I have secant. You guys have to remember your Pythagorean. There's a Pythagorean identity that says tan squared theta plus 1 is equal to secant squared theta. So that's what I'm going to do. I'm just going to make some substitutions. So it's 1 squared because tan is 1 plus 1 is equal to secant squared. So 2 is equal to secant squared. So secant, in order to solve for secant, I have to square root. But if I square root, I should get plus or minus rad equal 2. Okay, I should be getting plus or minus rad 2. But because I'm in quadrant 1, remember that all students take calculus. I'm in quadrant 1, that's all, so I'm going to take the positive one. So rad equal 2 would be your final answer. Okay. All right, the next problem I want to take on is number 5. It says cosine theta is equal to negative 4/5. Sine theta, I want to look for, and then I'm between 90 and 180. Remember, this is in quadrant 2, right? Remember, all students take calculus. Quadrant 2, sine is positive, so I'm going to take the positive answer. So the theorem that I'm going to use is sine squared. It all really comes down to you guys memorizing your Pythagorean identities. Is equal to 1. So as I plug stuff in, I get sine squared theta plus negative 4/5 squared is equal to 1. So I get sine squared theta plus 16 over 25 is equal to 1. The negative goes away because you're squaring it. Next thing you want to do is you want to subtract 16 over 25 to both sides. So I get sine squared theta. So it's 1 minus 16 over 25, which is essentially 25 over 25, which is 9 over 25, which is sine theta. And once I square root, I get 3 over 5 plus or minus. But remember, we're in quadrant 2, and we know sine is positive, so it's positive 3/5. Okay, finally, the last problem I want to do from this type of problem is number 9. It says cosecant theta is equal to negative 2. Cosine theta, I'm looking for cosine theta, and it's between 180 and 270. So this is quadrant 3. All right, for this problem, I'm looking for a pattern with cosecant and cosine. Since I'm focusing on cosine, we should convert cosecant. If you guys remember, cosecant is 1 over sine, right? So that tells me that sine theta, right, if I want to flip it, should equal to negative 1/2. Right, and the idea is that I'm flipping it. If cosecant is negative 2, then sine, the reciprocal of it, should be negative 1/2. From here, all I'm going to do is I'm going to use the same theorem that I did before, the same identity, plus cosine squared theta is equal to 1. And I'm just making my substitution. Negative 1/2 squared plus cosine squared is equal to 1. So I get 1/4 plus cosine squared is equal to 1. And now I'm subtracting. So cosine squared theta is equal to 1 minus 1/4. So 1 minus 1/4, that's 4/4 minus 1/4. So that's 3/4. So that's 3/4. So I get cosine squared theta is equal to 3/4. Now as I square root, I'm square rooting the top and the bottom separately, right? So it's radical 3 on top, and then the square root of 4 is 2. Because I'm on quadrant 3, all students take calculus. Only tangent is positive in quadrant 3. That means I'm looking for the negative cosine. Okay, and that's how you would do that problem. All right, I want to do a couple more. Let's do number 15. 15 looks interesting. So number 15, it's cotangent theta is equal to secant theta. Oh, no, sorry. Cotangent theta is equal to secant theta. Or times secant theta. I want to reduce. Remember, the rule of thumb in general that you guys should do is convert everything cosine and sine, right? So cotangent is cosine over sine. Secant is 1 over cosine. Cosines cancel out, so you get 1 over sine left over, right? Because these cancel out. And then 1 over sine is cosecant. So your answer is cosecant theta. Cool. The next one I want to do is 17. 17 is a little tricky. I have tangent theta. Plus cotangent theta. So once again, I'm going to convert everything sine cosine. So this is sine theta over cosine theta plus cosine theta over sine theta. Right now, because I do want to combine these things, because I want to combine them, I need an LCD. So the LCD, remember, you're looking at your bottoms. I see a cosine and I see a sine. So your LCD is cosine theta times sine theta. So here I'm multiplying sine top and bottom. Then here I'm multiplying cosine top and bottom because that's what they're missing, right? So now I get sine squared theta plus over sine theta cosine theta plus cosine squared theta over sine theta cosine theta. If you notice, the bottoms are exactly the same now. And because the bottoms are the same, we can combine it. So I can get sine squared theta plus cosine squared theta over sine theta cosine theta. Now, if you guys recognize, this is something nice. Sine squared plus cosine squared, that's 1. So I get 1 over sine theta cosine theta. Okay, this is kind of the tricky part of this problem. You kind of want to split it up. You want to rewrite this as 1 over sine theta times 1 over cosine theta. You're allowed to do that because if they're only multiplying, you can split it up however you want because they are multiplying. 1 over sine is cosecant theta times secant theta. Okay, this problem's a little tricky for sure, especially this first little step right here. That's probably the hardest step. But you're using algebra rules. Don't be kind of messed up or confused that, oh my gosh, I see so many sines and cosines, I'm getting confused. No, pretend they were x's and y's, right? You guys can probably do this if there were x's and y's. Oh, I find the LCD, I add, I multiply, I split up. I can do whatever I want with that. Okay. All right, the last problem I want to do is 19. It's 1 minus sine squared theta over sine theta plus 1. Okay, this one's kind of cool, and it requires you guys to memorize your a squared minus b squared property, right? If you guys remember, this is a minus b times a plus b. We're going to apply the same thing to the top. You see how we have 1 minus sine squared theta? It's going to be 1 minus sine theta times 1 plus sine theta. That's the idea that they want you guys to get right there, that you could split it up. So that's what I'm going to do. I'm going to split up 1 minus sine theta times 1 plus sine theta. On the bottom, I have sine theta plus 1. If you guys really check it out, these two things are exactly the same. Yeah, the order switched, but the signs are still right. Like one is positive, sine is positive, so they're the same thing. They essentially cancel out, so your final answer is 1 minus sine theta. Okay. And finally, 21. I have sine squared theta plus cosine squared theta over 1 minus cosine squared theta. Same thing. If you guys look at the top, that's nice. That's 1. That's 1, right? That's straight up just 1. Sine squared plus cosine squared is straight up 1. 1 minus cosine squared theta. Now the bottom is a Pythagorean as well. Remember, if we have sine squared plus cosine squared theta is equal to 1, you have the ability to move things. So I want a 1 and a minus cosine squared theta. That's what I'm going to do. I'm going to subtract cosine squared theta. So I get sine squared theta is equal to 1 minus cosine squared theta. And that's kind of what the bottom would be. The bottom is 1 over sine squared theta. 1 over sine squared theta is really cosecant squared theta, and that's it. Because 1 over sine is cosecant. If they're squared, then they're squared. Okay? You guys need to make sure that you guys memorize the identities. I can't stress that enough. You can't really do this without memorizing the identities. The quicker you guys memorize them, the better. I know that you guys are on break or whatever, and that you guys are just like chilling or being lazy, or maybe have a lot of work for other classes. But you guys got to remember that, you know, what you're doing now is important for next year, because you're going to do this similar stuff next year, right? And some of you guys are seniors next year. You guys don't want to fail it when you guys become seniors. So it's better just to get it down now. And it's not that bad. It's memorizing like a handful of rules. Okay, so please, please, please do your best to memorize them. If you guys are having trouble, like always, contact me. You guys know how to. All right. Until then, have a safe weekend, guys.